Find the derivative of y equals t cubed plus t divided by t squared minus 4 quantity squared. Y here is the quotient of two functions, t cubed plus t, and then t squared minus 4 quantity squared. So overall we will make use of the quotient rule for our derivative. Y prime, or dy dt, will be the derivative of the numerator. Power rule, bring the power down, subtract 1 from it. Derivative of t is a 1, times the denominator left alone minus the numerator left alone times the derivative of the denominator. Now the denominator is a quantity squared, so we'll start with the power rule. Bring down the power, subtract 1 from it, it'll be a 1 power now, and then multiply by the derivative of the inside to complete the chain rule. And then all of this is over the denominator squared. Now in the numerator we have a 3t squared plus 1 times a t squared minus 4 quantity squared minus, now the second term I'm going to multiply this 2 and this 2t and put them first. 2 times 2 is 4 times the t. It's customary to bring the constant and the smaller expressions to the front. We're not going to FOIL that expression out that's left with it because we actually have a common factor in the numerator. Actually, there's a t squared minus 4 in both terms. You can factor out the lower power. That's what we're going to be doing next. Over this denominator, now t squared minus 4 raised to the 2 and then raised again, you multiply those exponents, 2 times 2, and that becomes a 4. Now our next step is to work out the factoring. We have a t squared minus 4 to the second and to the first. We can factor out the lower power of the 2, that's the first power. So t squared minus 4 to the first power. And that will give us, if we remove one of them, it takes that out and it will take all of that out. There's what we should have left. So 3t squared plus 1 times t squared minus 4 to the first power minus 4t times t cubed plus t. All of this over t squared minus 4 to the fourth power. At this point we can cancel, since we factored this out, with one of these down here, and that will leave us with 3 of them down there. At this point we're now going to FOIL this expression because we're going to be able to combine like terms in that numerator. So foiling that out, I'm going to have a 3t squared times a t squared. That'll be 3t to the fourth for our first. Our outside 3t squared times a negative 4 will be negative 12t squared. Our inside 1 times t squared will be a positive t squared, and then our last 1 times negative 4 will be a negative 4. And then I'm going to distribute the negative 4t into this expression here. Negative 4t times t cubed is negative 4t to the fourth, and negative 4t times t is a negative 4t squared. All of this divided by t squared minus 4 quantity cubed. Now we're going to combine like terms together in the numerator. So y prime, or dy dt, equals to, in the numerator we have two terms that have a t to the fourth, a positive 3 and a negative 4. So that's negative t to the fourth. We have 3 terms that have a t squared. We have a negative 12, a positive 1, and a negative 4. Negative 12 plus 1 is negative 11, and negative 4 is negative 15, so negative 15 t squared. And then there's only one constant in there, negative 4. All of this divided by t squared minus 4 quantity cubed. Another thing we can do is factor out the negative. There is a negative in every term in the numerator, so it's a good idea maybe to factor that out. And that factor, we'll just put it in the front, and these will become opposite sign, so that will all be positive. And then over the t squared minus 4, quantity cubed. There's no other common factors in the numerator, and the numerator does not factor any further. So we will leave it just like that, and there is our simplified version of the derivative y prime or dy dt.